Now we're going to do another video on graph characteristics. All right, this is our real life scenario. Flora wants to earn money selling cakes. Her ingredients cost her $50. Design a rule for her profit if she sells cakes for $10 each. So the rule, remember, is in the form of y equals mx plus b. And this is her starting point. It's her y-intercept. It's her starting point. Her ingredients are costing her $50. So she doesn't have plus 50. She has minus 50 on the end. So minus 50. And she is selling her cakes for $10 each. That's a positive thing. So it's going to go up $10 each time. Also, each lets you know that it's the slope. So y equals 10x minus 50. All right, now I've already designed the table so that you can follow along as well as the graph. But if you look at the table here, we're starting with 0 and she's got negative 50 because that's what her ingredients cost her. For every cake she sells, she makes $10. So this is decreasing by 10 each time. In other words, it's increasing, by 10 each time. It's going up by 10. Now I only went to 8, but we're just going to assume that she could just keep selling cakes. So I came over here and I didn't number everything, but each one of these is worth 10 going down, okay? And each is worth 10 going up. That's the easiest scale. This is the graph. This is the 0.0, negative 50. This is the 0.50. Now, we're going to occasionally look back at that to do everything that we need to here. Remember, domain is all possible x's in the real life scenario. She's starting out with 0 cakes that she can sell. Remember, this is the x. So if you look at the table, it's the x category. Now, we only went through 8 on the table, but she could keep going if she had a bunch of materials, a bunch of cake ingredients, she could just keep going forever. So if we extended that line, I wrote an arrow on the end of it. It's got a starting point here, but it's going on forever. So we said 0 to infinity there. That's set notation. That's a interval notation. Set notation says x such that 0 is less than or equal to x is less than or equal to infinity. I literally just take these and put them here with the x in the middle. Now, the one thing that I do see here is we don't want less than or equal to on infinity. Infinity will just be less than because it doesn't touch it, okay? So that's x less than infinity, okay? We don't ever touch infinity, so it's not going to have an equal to there. It's an open circle, so it wouldn't have an equal to. It would just be less than. All right, our range, the interval notation goes from negative 50 to infinity because we're starting out $50 in the hole, and then our profit's increasing. So same thing over here. Instead of writing x, I write y. Y such that negative 50, that's the end, is less than or equal to y is less than infinity. Then my y-intercept, if you look at your graph now, all you got to do is read your graph. The y-intercept is 0, negative 50. The x-intercept's 5, 0. So you just go over and put that in. You just read your graph and look. Now, if you want to look at the table, the y-intercept is where x is 0, okay? And the x-intercept's going to be where y is 0. That's another way to find it, okay? And my x-intercept, my 0 is the x-coordinate of my x-intercept, which is 5. All right. Now, increasing and decreasing. This function, if you look back at the graph, is increasing. It is increasing all the way from 0 to infinity. It never decreases. A line will either increase or decrease. It won't do both. So this one's increasing from 0 to infinity, x such that 0 is less than or equal to x is less than infinity. Now, this graph is positive. Let's go back and look. And you can look here on the table. It starts becoming positive right here. Look, these numbers are positive. When we talk about the word positive, we are talking about y being positive. Where is y? Positive. And y is positive up here. Okay? So from 5 all the way to infinity, this is infinity, infinity. Remember how I taught you to do that? So from 5 all the way to infinity, the graph is positive. From 0 to 5, it's negative. So let's go and let's look at that. So it is positive from 5 to infinity, x such that 5 is less than, x is less than infinity. Now I don't have an equal to symbol here because at 5, the point is 5, 0. And 0 is neither positive nor is it negative, but it's a boundary. All right, for negative, and I already mentioned that, that's from 0 to 5. So x such that 0 is less than x is less than 5, because that's where the graph is negative. All right, end behavior. As x approaches 0, f of x approaches negative 50. Look at the graph. Read the graph. Look at the ends. This is the end. As x approaches 0, f of x approaches negative 50. As x approaches infinity, f of x or y approaches infinity. You literally read the ends. You just read it. You just look at the end and see what the end is doing. That is it. You read the end and see what it is doing. X, Y, X, Y. All right, let's look at this graph. All right, we have this graph here, and I began by labeling my negative infinity, infinity, and my infinity, negative infinity. Remember, I get it from here. This is my x, this is my y, x, y. This is my x, this is my y, x, y. And the other points are labeled. So my domain stretches from negative infinity all the way to infinity. That's my domain. My range goes from negative infinity all the way to infinity. That's my y's. My x-intercept, that's this point, 3, 0. My y-intercept is a point 0, 6. All right, the 0 of the function is the x-coordinate of the x-intercept. All right, this graph is decreasing. It is going down. It is different from our real world example that we had. But this one is going down all the way from negative infinity to infinity. All right, it is positive here from negative infinity to 3. This is where, I need to use a different color. This is where y is positive. Where that occurs on x is from negative infinity to 3. This down here is where y is negative. Where that occurs on x goes from 3 to infinity. Thank you.